Hello guys, this is Utkarsh Grover again. I'm here with another video of ECE 6303 homework 4 problem number 2. So the question number 2 goes like this. The random variable x is uniform in the interval -1 to 1. Find g of x such that if capital Y is equal to g of x, then small y base y is equal to e to the power minus y u of y. So here we go. As we are given in the question, x is uniform in the range -1 to 1, y is equal to g of y, then the value of small y will also be equal to e to the power minus y u of y. So making a graph out of it, when we calculate the capital of fy, we will get this curve. We'll also get this capital, so we'll get the capital f of y. So capital value of capital f of y will be equal to capital of f of x will be equal to 1 upon 1 plus x by 2. So when we calculate and keep the values of capital of f of x, that is equal to 1 plus x divided by 2, we'll get a graph something like this, where the value of x is this is the axis, this is the +1 on y-axis, this is +1 on x-axis, and this is -1 on x-axis. And the graph of capital F of x goes like the capital F of x goes like this. So when we map it on capital F of y, we'll get something like this. It's a curve, exponentially rising curve, that is 1 minus e to the power minus y, capital F of y, bracket y. So after setting capital F of x, that is equal to 1 plus x divided by 2, we have 1 minus y e to the power minus y is equal to capital F of y. We have, after calculating these, we have small y is equal to minus of log 1 minus x divided by 2, that is equal to g of x. So these both of these values are equal, because initially we were given y is equal to g of x, and hence after calculating this, we get small y is equal to minus log 1 minus x by 2 is equal to g of x. So for interval where x lies between -1 and 1, we also have this information in the question that x is uniform in the range -1 to 1. Hence we are taking this range. This is small brackets, so small bracket means -1 and 1 not considering. So value smaller than -1 and values smaller than 1 and values greater than -1, excluding -1 and 1. So we are representing here like this, that is x lies between -1 and 1, where we are excluding -1 and 1. For x is smaller than -1, x is smaller than -1, smaller than equal to -1, the value of g of x equal to 0, and for x greater than equal to 1, the value of g of x is equal to infinity. So now after having this information, we are going to plot this graph. So value between we have the value of x that lies between -1 and 1. So that's for sure that the value of x, so the value of y will exist between -1 and 1. When we take the value of x that's smaller than equal to -1, the value of g, so this is our x-axis, this is our y-axis, and this is our graph g of x. So when we are considering that x is smaller than equal to -1, that means the x lies in the region, this region. So the value of graph of gx equal to 0. That means it will cut on -1, and then after -1 it will be 0. It will be 0. So this is done. When considering g of x that lies between -1 and 1, we have this graph. So we have a graph like this, which is going exponentially up because of this function. When you consider the area where x is greater than equal to -1, we find that the value of g of x is equal to infinity. That's why our graph is tending towards infinity at x equal to 1, and for any value which is greater than 1, our graph will tend towards infinity, and like it'll go towards infinity. So this was our second question. Thank you.